Hello everybody, welcome to this next lecture on probability, introduction to probability. This is a basic course. So in the last two videos, what we have seen is that you have an uncertain situation. This is a situation from your life which is not deterministic. It means that there is some some amount of uncertainties involved. So this is your uncertain situation, right? So it may have more than, uncertain situation means the outcome is more than one, right? The simple thing we can say, like, it has more than one outcome. So suppose this has outcome 1, outcome 2, outcome 3, outcome 4, and we would like to know what is the likelihood of this outcome, what is the likelihood of this outcome, what is the likelihood of each of the outcomes. So what are the likelihoods? So this finding out that what are the likelihoods is nothing but probability. Like, this is mathematically when we try to find this thing, so this is probability, right? So we call these likelihoods as probabilities. So this is the subject of probability mainly concerned with. And in the last two videos we have seen that whenever you have an uncertain situation, then to mathematically model it, to make a model, to make a probabilistic model, because whenever you are trying to bring mathematics into picture, so you need to know need to bring some mathematical terms or mathematical things like sets and things like that. To make a mathematical model, we need two things. One was your sample space. So sample space was set of all possible outcomes, and then you had a probability law. So what was your probability law? So it was a function from set of all events, right? So you to every event you will assign a number, and that number is between 0 and 1, right? So this is your probability law, right? So that we denote the sample space with omega, and a set of all events will be power set of omega, because it will be set of all events means you have to take every possible subset here. So that is your event, right? I told you event is a subset of sample space. So this should satisfy. We denote this function with p. So we had seen that probability of this whole set omega, this is power set of omega. Let me change the notation. So this set here is power set of omega, right? So probability of omega, that is the whole sample space, should be 1, right? This we call as normalization property, right? And we had that probability of any event should be greater than or equal to 0. This is positivity. And then we had probability of A intersection B, A union B should be equal to probability of A plus probability of B if A and B are disjoint. So this was your additivity property, right? So if you ask me that from where these properties are coming, so these are you can just look at the real life situation, and these are intuitive. Like, you actually want them to be true. For example, you don't want likelihood to be negative, and you want that if two events has nothing in common, then obviously the likelihood of their union should be the sum of the likelihood of each of the event. And this normalization property, this is for our convenience, right? So we want to keep everything between 0 and 1, right? So it's just a normalization. You can also keep it as 100, but as a convention we keep it 1. Okay, so this is what we have already done, right? Now the question is, how do we, given a situation, how do we find out the sample space, and how do we assign a probability law, right? So now you see, given a situation, most of the times the sample space is already fixed, because if the situation is given, you have a sample space already, right? You just look at the possible outcomes, and that will give you that what is the sample space. But the probability law may be there may be more than one probability law, there may be more than one function which can satisfy all these three properties, right? So let us see how do we do it. So I will just take some examples and we'll look at it, right? So the first example I'm taking is that you toss a fair coin. Right, so when you toss a fair coin, suppose you have a coin, it has two sides, head and tail, you toss it. So what are the possible outcomes? So it's very simple that you can just write down your sample space. So it's just head and tail, because these are the only two possible outcomes, right? Now this is simple, right? So you can just make your first thing, which is your sample space, right? Now you have to assign a probability law, right? So for here in this situation, what you can think is that since the coin is fair, so it means that both the outcomes are equally likely. So since coin is fair coin implies both the outcomes are equally likely. It means that what is the probability of getting a head is same as probability of getting a tail, right? And also because these are the only two outcomes, right? So I have this normalization property which tells me that probability of the sample space should be 1. So now here the sample space consists of head and tail only. So probability of head union tail should be 1. Now I use additivity, which tells me because getting a head and getting a tail, they are disjoint. So probability of head plus probability of tail should be 1, right? So this is from additivity, right? Although this is very simple, but I just want to show you that this is how you will deal with complex situations too. So now these are equal. Let us call them small p. So this is p plus p is 1. So that gives you 2p is 1. That gives you p is 0.5. Right? So we get that this number here should be 0.5. So or half. Okay, so you see this is what we do, that getting the probability of getting a head is half and probability of getting a tail is also half, right? Now what is your probability law? Because probability law is actually a function from set of all subsets of all like set of all events. So what are your events? So this is your set of all events. So here you see what are your events. The subsets are phi, only head, only tail, or head and tail. Right, now you can assign to these sets some numbers. So what is the probability of getting nothing? That is 0. So p of phi is 0. Probability of getting a head, p of head is half. Probability of getting a tail, p of tail is half. And probability of getting a head or tail is 1 by 2 plus 1 by 2, that is 1, right? So this is your required probability law. So this is your probability law, right? So you see this is how you can construct your probability law and your sample space, right? So let us look at some more situations. So next example is 3 coin tosses, right? 3 fair coin tosses, right? So you have you have 3 coins, you are tossing them. You have first coin, second coin, and third coin. Or what you can do is you have a single coin and you just toss it 3 times. Okay, now you see here what are the possible outcomes. Sometimes it is not possible to write all the outcomes, right? Because the sample space may be big, but here we will write. So the first thing is you get head all the 3 times, or you get 2 heads and 1 tail. So this is head tail, or you can get head tail head, or you can get tail head. Then say 2 tails, so you can have tail head tail, you can have tail head, or you can have head tail. So these are 2, 4, 6, 7, or you can get all the tails. So there are total 8 outcomes. So this is your sample space. So this is your sample space. This is your sample space. Now let us see how we can assign a probability law. Right, now you see here. So can you think of how you are going to assign a probability law here? So you see, we assume that each possible outcome has the same possibility because they are fair. So there are total 8 outcomes. There are total 8 outcomes. Total 8 outcomes. And because of fairness, we imply that each outcome has same probability, right? So call it P. And because there are total 8 outcomes, so it means that 8 into P, the sum of the probabilities is 8P. That should be 1. It means that P should be 1 by 8. So it means that probability of each single outcome is 1 by 8. Right? Now, we have to assign a probability law. For that, we need to assign probabilities to the event. Now, there are so many events possible because for this set, there are 2 raised to power 8 subsets, right? So it means that there are 2 raised to power 8 events. So we will not be able to list them all here. So, but what we can say is, suppose I have this set head, 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 tail. So what is the probability of this set? So that will be 1 by 8 plus 1 by 8. So this will be 1 by 8 for this, 1 by 8 for this. So that is 2 by 8. So we can say that probability of an event will be equal to 1 by 8 times number of elements in that event. Number of elements in that event. Right? So if I ask you what is the probability of an event which is equal to, event is getting exactly 2 heads. Exactly 2 heads. So now you see there are getting exactly 2 head is 1, 2, 3. So we have head, head, tail, head, tail, head, or tail, head, head. So these are the possible outcomes in which we are getting exactly 2 heads. So what is the probability? So probability will be 3 by 8 because it contains 3 elements, 3 outcomes, and we have to multiply with 1 by 8. So this is how you can do the things easily. When here you see 2 things are important. One is equally likely. That is why you were able to get this figure of 1 by 8. Right? So equally likely is because of fair coin. Right? So but obviously if you you don't have equally likely, then also if somehow you know the probability of single outcome, then you can use the additivity law to get the probability of any given event. So what I can tell you is there is something called discrete probability law. Here you see everywhere the outcomes were finite, right? So we have discrete probability law. So here in this video we are just talking about discrete. In the next video we will be talking about continuous. So what is discrete probability law? So it says as if the sample space consists of a finite number of possible outcomes, let me write down so that you understand it well. If the sample space consists of finite number of possible outcomes, consists of finite number of possible outcomes, right, then the probability law is specified by, then the probability law is specified by probability law is specified by probabilities of event that consist of single element. Probabilities of single elements, single outcomes. This is what we have done, right? In the above 2 examples, we decided what is the probability of this single element, what is the probability of this single element. Here also we decided what is the probability of this single element and what is the probability of this single element, right? And then in particular, and after that, probability of any event, suppose it contains S1, S2, Sn, that will be equal to probability of S1 event plus probability of S2 event plus so on probability of Sn, right? So these are the events containing single outcomes, and you have already decided what are the probabilities of single outcomes, and then you can give probability to any outcome, right, using the additivity law, any event, sorry, right? So what we do, so step is, so in case of discrete probability law, so you have to decide probability of single outcome, right? Then probability of an event is equal to the sum of the probabilities of the single outcomes in that event, right? So this is what is discrete probability law, right? And if here further we can say, if all the outcomes are equally likely, and total outcomes are n, then probability of a single outcome will be equal to 1 by n, right? So when you have probability of single outcome is equal to 1 by n, then probability of an event will be equal to number of elements in that event into 1 by n. So that is simply number of elements in E. So probability of an E will be number of elements in E divided by n. Okay, so let me write like this so that you are not confused with n. So this is how we have discrete probability law. So this is valid only when you have finite number of outcomes in your sample space. So this is only when you have finite number of outcomes in your sample space, right? Okay, so we'll do one more example before stopping. In the next video we will be talking about continuous sample spaces, right? So we will be talking about continuous probability law. So this video is, you see, the topic also is discrete models, or we can call it as discrete probability law. So this video we are discussing discrete probability law when number of outcomes in your sample space in omega is finite. So this is that case, okay? And this is most of the times we have this case very often, right? That we have a finite number of outcomes. So let us just look at the last example. So here I am saying that you have two fair coins, right? Four-sided. Four-sided means you have this option of getting, so four-sided not coins, I'm sorry, dice, right? So four-sided means you have a pyramid type dice. You will have 1, 2, and then you have 3 on the first like front face and 4 here, right? And these are fair. So what are the possible outcomes, right? So you can just see, you can get 1, 2, 3, 4 on the first dice. You can get 1, 2, 3, 4 on the second dice, right? So you have these possibilities: 1, 2, 3, 4. 1, 2, 3, 4, right? So your outcomes will be like this. Okay, you can just draw like this, right? So there are total 16 possible outcomes because you are throwing 2 dice, right? So you are rolling 2 dice, so the total 16 possible outcomes, and because of fairness, all the outcomes are equally likely. So you will say that probability of each outcome will be equal to 1 by 16, right? Now you can give, once you have probability of a single outcome, you can compute the probability of any event. For example, if I ask you what is the probability that the first roll is equal to the second, right? So now you see here these are the outcomes where the first roll and second roll are equal. So we are saying either you get 1, 1, or you get 2, 2, or you get 3, 3, or you get 4, 4. So what is the probability? So now because they are 4 elements and the probability of each element is 1 by 16, so it is 4 into 1 by 16. So answer is 1 by 4. Okay, so you can like this you can calculate the probability of any event. If I, for example, if I ask you what is the probability that at least one roll is equal to 4, at least one roll is equal to 4. So here you see this is 1 2 3 4, 1 2 2 3 4. So these are the places where you are getting at least 1 4, this, right, and here. So there are total 1 2 3 4 5 6 7, 7 outcomes where you are getting at least 1 4. So answer will be 7 by 16, right? So this is how you can assign probability to any event, right? So I hope you understand that how you are going to, you know, assign a probability law in case of finite number of possible outcomes. So this is called discrete probability law, right? So this is important. So I want you to practice it. You can have some questions from the book which you are following, and then you can just do some problems. And if you have any doubts or any queries, please write in the comment box. Thank you for watching. Please share this video and subscribe to this channel.